In this module for week 8, we'll continue to talk about pointers and references and their different uses, especially when calling a function and then how they're being used in the parameters, potentially to avoid making copy by using const qualifier to avoid modification, or on purpose allowing modification to use side effects that are desired. And we'll focus on a few variation of functions for swap values just to illustrate the concept. So let's look at a basic example. We have two integers, a and b, and we want to swap the value without using in the main a third variable and using the value. So we define a special function swap such that the swapping happens here on the fly. The function doesn't return any value, but as a side effect has the value inside A and B replaced. So in this case, we use as a parameters a pointer to an integer for both A and B. Notice that the A and B in the main and the A and B in the function are distinct. In fact, they're even different types. So we can use the same name just as a reminder of the value, but this will work in general. There is no conflict. So let's step by step go through the program. And so we will have in the stack frame of the main A, then the declaration of B with values 6 and 12. And then we look at the function swap, and now we pass as parameter the pointers. So you see that the reference to operator, the pointers to the variable. So we have an int star in the frame stack of the function call. Now we have two local variable a and v, the argument of the function, that are pointer to the original a and b. We have also a temporary variable where we start assigning through dereferencing the value of the actual variable a by dereferencing the pointer. We do an assignment assign the values minus 12 in the location of a, and then using the temp, we assign that to the location of b. Once we come back from the function, you see the two values have been swapped, and so we obtain the effect that we were looking for. So this is a first use when we go through the use of pointers. Now, let's look at, for example, the case of a string, kind of an array of characters, and how can we swap the values, not the original array, but pointers of those. Now here, notice the difference here. We use a char star reference. So those are references to pointer to the function. The way we do that is that because when we now use the pointer to the first element of the string as the location where the array starts. So if we start running the application, we have char a array hello, then we have b world. Now we assign to a char star the head of the array, basically the pointer to the first character. And so as a string, this will find the array. And then pointer b, the reference to b. Now, once we go into the swap function, you will see that char star ampersand a, it's a reference to the pointer. And so it actually makes the same modification. So now we have as a temporary variable, a char star temp. At this point, now we have saved the location of the array. Now we reassign the location of B so that it points to the other array, and then we go and assign the location of B pointer to go into A. So the original array are in the same location, and the other two arrays have been swapped. So let's look at that actually inside Visual Studio just to get a sense. So this is the code that we were looking at before. Let me clear the screen. And so here we have the swap function with the reference to a pointer to an array. And so here we have the two assignments, the creation of the array, and then the assignments to a pointer. So now we use this as a breakpoint. So we are in debug mode. Let's just rebuild to make sure. So we build the solution. We have this location where the program stops. And so now we can start debugging. And so the debugger stops here. We can use these elements to make progress into the code. And so we move forward one line. And so char A hello, and we can see here that it's assigned to the first string. Then we step forward, char B world. And now we start working with the arrays. A pointer is assigned to A. So though A array and char star effectively both behave as a string, and then B is also assigned. So you see the A and A pointer point to hello, B and B pointer point to hello. Now I step inside, so I use this other element to see what happens in the swap function. So we have the references to the array that go hello world. And now we start swapping the value here, temporary assignment the other way around, and then we come out of the function. And now you see that A pointer points to world, where B pointer points to hello. So basically A pointer and B pointer have been swapped in terms of references, while A and B are the same. And so A and B do hello world, while BA do world hello. And so this is just to clarify. Notice that if I remove the reference here and I really pass a pointer, so now this value get copied, and so the information is not shared anymore, right? And so here I could rebuild the project first. You want to start debugging? Yes. We recompile, start. And so here we start stepping forward as usual. So we have hello, hello, world, world. Now we step in the function, and locally things are happening kind of in the same way. There is an exchange. But now when we come out of the function, because those were not references but just made a copy, the swap does not have an effect to A pointer and B pointer. And so A and A pointer remain pointing to hello, and B pointer also point to both to world. So effectively, this didn't do anything in terms of the target computation. So again, if we bring back the ampersand, and then we rebuild the solution, this goes back to the functionality we were expecting. And so then we'll do a little bit more quickly, go to the end, and here we have the swap between hello and world. So this gives a sense of how things can be used in different ways. And now let's look at how pointers and constant can be combined together if we want to sometime not allow to modify elements. And obviously const does not require to use pointers. It's a qualifier that can be used in many different situations. For example, if I have const int num 100 and num2 is 200, so now if I assign a num to the value 99, is that legal or not? Now, if you think about for a moment, so normally without a const qualifier, this would be allowed. But because we say the int behave like a constant, the compiler disallows this, and this is not a valid statement anymore. Similarly, here we look at a const int star 9 pointer equal to the reference of a num, which is the same as int const star. And so can we assign now as a reference to 99, the reference to the pointer, the value 99? So even in this case, given that we have declared that the pointer is pointing to a constant integer, so that integer cannot be modified. So it's not that the pointer is constant, is the integer. So it's a pointer to a constant. So that the use of the dereferencing not allow to change the value. Similarly, num pointer num2, and then we assign that, and notice that num2 is the other variable. And so at this point, this is not legal still, because the declaration of pointer was a pointer to a constant. So even if we assign a variable that initially was not a constant, the declaration of the pointer is really what rules the situation. And so num pointer still prevents me to use the dereferencing for a modification. More examples. So now we do int star const pointer, and then we assign it to the, now is the pointer itself that is constant. And so the assignment, it's legal because we are not modifying the pointer, but we are modifying the object referenced by the pointer. So we would not be able to modify, so the pointer is assigned once. We could not change the pointer itself, but the value pointed by that, it's a valid modification. And num pointer equal num2, is that legal? No. As I said, just we cannot modify, reassign the pointer to a new value. This was num and num2. And so those are different way to combine const and integers. And so we have to be in references and pointers. So we have to remember that there is a distinction between having a variable that is a constant, a variable that is a constant pointer, or a pointer to a constant value. And depending on the situation, those things can be allowed or not. So this is a good summary that maybe you want to learn quickly in preparation, for example, for the next homework and the midterm. So going back to using references for a function call, let's say we store a very large array and we want to print it. A way to avoid making a copy of the array is to pass a reference. And so we declare the same type and then ampersand. Now, as we saw in the swap, this makes the function vulnerable to modify the vector even if it shouldn't. So what we can do is define this as a const references. So the function call use a reference so that the values are not copied, but then the use inside from the language itself prevents any modification. This is a similar way of achieving the same result by using a pointer instead of a reference. So we have a const vector pointer, and we simply call it by reference instead of directly with a name. Effectively, same result. As a last, we look at the classical swap function between integers. So this is something that you see all the time, similar to the version that we saw before. We saw using the pointer. You can swap two values by doing a reference. Let's go back to using Visual Studio. And so here we load the other project. So here we have the swap function that uses references to two integers. And so this has a side effect, make a modification. So we assign two value, we print them, we call the swap function, and then print the values again. So here we can now build the solution. Let's clean it and build it again. And then now we can run the program. Initially, A and B are 100 and 200. After the swap is 200 and 100. And again, similar to before, if you see, if I call simply int without the ampersand, we would, so let's recompile. So syntactically, the program is valid, but now when we call the function swap, A and B are copied, and so there is no side effect. So swap, the value before is 100 and 200, value after is still 100 and 200. Let's go back and add in the reference operator and recompile 100, 200, 200, 100. So this is the result that we want. And so, and this conclude this discussion of pointers. And after this, we'll go to the basics of using classes in C++. Thank you.